Well, students, today I will be discussing with you the phenomena of greenhouse effect. Well, before going directly to the topic that is greenhouse effect, now we all of us are well aware that this modern industrial societies they are characterized by the intense use of energy. So can you think of a day in your life without electricity or other sources of energy such as fuels for cooking and the transport? Now, these are the basic requirements to sustain our life. Think of all the things that we use. It will give us an idea that what we are doing, what are our activities. Now, this energy is required to produce them and reach them to you. You will agree that energy has been a crucial input in the current model of development. There is a close relationship between energy consumption and economic growth as measured by the growth of GDP, and this has been demonstrated by many researchers. Now, as the energy intensive industrial economies have expanded in the recent past, their adverse impacts on the environment it has also grown. Now, this aspect, the impacts of the industrial economics on the environment, it has gone under some sort of scrutiny in the past few decades, and we are trying to understand the role of energy in the economic development, and that will help us to develop models of environment friendly energy usage. Therefore, initially we can see that that we should have some sort of consensus among all the countries, whether it is developing countries or the developed countries, that that the sector of this energy with respect to the it is a relationship with environment environment and in a friendly manner needs to be looked upon. Well, students, in the previous slide, basically I have focused my topic with respect to the energy sector only. That I am putting this energy as a sole agent responsible for this greenhouse effect. Now, when we talk of this greenhouse effect is a naturally occurring phenomena that blankets the Earth's lower atmosphere and it warms it. Thereby, it maintains the temperature which is suitable for the living things so that they could survive. Now, if you see this greenhouse gas, it's a conventional greenhouse gas that keeps the air inside its chamber warm, water vapor and greenhouse gases warm this, similarly the earth here. Greenhouse gases they play a very important role in the balance of Earth's cooling and warming. Now you can understand it from this picture over here. Now there are estimates that in the absence of naturally occurring these greenhouse gases or greenhouse gas effect, the average temperature of the Earth's surface, it would go as low as minus 19 degrees centigrade, or instead of the present we have around on average 15 degrees centigrade this temperature. And at 19 degrees centigrade temperature, this Earth would be a frozen planet. As far as this greenhouse is concerned, glass house, we sometimes call it a glass house if it is covered with the glass, or a greenhouse. It is a small building. It is made up of glass chambers. Now here in this picture, it is covered with the polythene. Transparent light passes through this polythene, in which plants are grown. Here you can see these pots. These plants are grown in cold countries or where the climate is very cold. They can survive in this greenhouse. Now with the result, what happens by the effect of this greenhouse, there is a continued increase in temperature in this greenhouse, even when the outside temperature, that is the outside temperature here, this outside temperature remained very low. And by way of this low temperature outside and the maintenance of the inside of the temperature by this greenhouse effect, it protects all these plants, all these pots from the frost. Now this greenhouse effect, it's a process basically. It is caused by these greenhouse gases. These greenhouse gases, they occur naturally in the atmosphere. This process basically plays a very crucial role in warming the Earth's surface, makes the Earth habitable for the humans, for the plants, as well as for the animals. However, you can see two conditions over here. Due to human generated these greenhouse gases emissions, they upset the natural balance and lead to the increased warmth around the surface of the earth. Now you can see the sun emits energy that is transmitted to the earth. Because the sun is very hot, the energy is emitted in high energy short wavelengths that penetrate the earth's atmosphere. And here about 30% of the sun's energy is reflected directly back into the atmosphere, into the space, in fact, by the atmosphere, by the clouds which are present here and the surface of the earth. The rest of the sun's energy, is absorbed into the earth system. The earth re-emits energy back into the atmosphere. You can understand it by way of these numbers 1, 2, 3, 4, 5 and 6. The earth re-emits energy back into the atmosphere. Because the earth is cooler than the sun as compared to the sun, the energy is emitted in the form of infrared radiations. Please remember, at wavelengths is longer than the incoming solar radiations or solar energy. Now we see what role these greenhouse gases they play. Greenhouse gases in the atmosphere absorb much of the long wavelength, that is infrared radiation, emitted from the Earth's surface. prevent it. What they do, they prevent it from the escaping from the Earth's surface. The greenhouse gases then re-emit this energy in all directions, warming the Earth's surface and lower atmosphere. You will understand here by this picture. Now, what is our common observations? What role basically humans have played in changing the normal course of the atmosphere? Now we have seen that it is on record the atmospheric concentration of the greenhouse gases, they have increased significantly over the past 2 centuries, and it is largely due to human generated carbon dioxide emissions. That carbon dioxide emissions are released into the atmosphere, or their concentration into the atmosphere, by way of we do burning of fossil fuels, and we also do deforestation. Now, what is the difference between, basically there are two types of these greenhouse effect. One is natural greenhouse effect is, and another is human enhanced greenhouse effect. On the left part it is the normal, it is the natural greenhouse effect, and on the right side you can see here, over here you can see here, this is the human enhanced greenhouse effect. Now this increase has amplified, this here has amplified the natural greenhouse effect by trapping more of the energy emitted by the earth. This change causes earth's surface to increase. Basically this is the human induced greenhouse effect, and this is the natural process of the greenhouse effect. Greenhouse effect is very important, but what we did, we have enhanced this greenhouse effect by way we have the temperature near to the surface of the earth, it has increased. This is the process starting from 1, 2, 3, 4, 5 and 6. Now students, now coming to greenhouse gases. Now greenhouse gases, here I mean to say those gases which are part of the atmosphere. These are both natural as well as the anthropogenic. Okay, that means human induced greenhouses, and these gases, they absorb and remit that those infrared radiations. First of all, coming to the water vapor. Number one, first of all I will come to water vapor, the moisture present in the atmosphere. Water vapor is basically the biggest contributor to the greenhouse effect, and humans are not directly responsible for emitting this gas, because we are not responsible for emitting gas in the quantities sufficient basically to change its concentration in the atmosphere. I'm talking of this water vapor. However, carbon dioxide, and as I have mentioned, carbon dioxide somewhere here. However, this carbon dioxide and the greenhouse gases is increasing the amount of water vapor in the air by boosting the rate of evaporation. Okay. Now, unlike this carbon dioxide, which can persist in the air for centuries, water vapor cycles through the atmosphere quickly, evaporating from the oceans and elsewhere before coming back down as rain or snow. Okay. Since the rate of evaporation rises with temperature, the amount of water vapor in the air at any one time is strongly related to the amount of other greenhouse gases in the air. This is a story of the water vapors. Now coming to carbon dioxide here. Carbon dioxide is the primary greenhouse gas, and it is emitted through the activities of the humans. Carbon dioxide is also naturally present in the atmosphere as part of the Earth's carbon cycle, as all of us know it very well. That circulates, that is the natural circulation of carbon among the atmosphere, among the oceans, among the soil, among the plants, and as well as the animals. Now you should understand that human activities are altering the carbon cycle, both by adding more carbon dioxide in the atmosphere and by reducing the natural sinks, like deforestation we do, which otherwise removes carbon dioxide from the atmosphere to the process of photosynthesis, everything. We don't need to go into details over here. This is enough as far as we are discussing the greenhouse effect or greenhouse gases. While carbon dioxide emissions come from a variety of natural sources, human-related emissions are responsible for the increase that has occurred in the atmosphere because of the industries, and we attribute it to the industrial revolution. Now coming to the main sources of this carbon dioxide, this combustion of fossil fuels, generally producing electricity, are the main sources which contribute to this carbon dioxide. Gasoline, combustion of these fossil fuels, gasoline, this diesel used for this transportation also contributes higher amounts of this carbon dioxide. Industrial processes, they also emit a lot of this carbon dioxide into the atmosphere. There are basically some processes, they do not involve combustion, but they produce good quantities of this carbon dioxide. The, for example, by the production and consumption of mineral products such as cement, the production of metals such as iron and steel, and the production of certain chemicals, etc. Now, as far as the trends of this carbon dioxide are concerned, there have been changing trends in the emissions of this carbon dioxide. And number one, what I believe and what I perceive, this population growth is also responsible for it. Economic growth is responsible for it. Changing energy prices, they are also basically, these are the changing trends as far as the emission is concerned. New technologies are coming. The changing behavior among us, the people, it is also changing some sort of trends. Or the overall the increase, we have seen that between 1990 and 2010, say for these 20 years, the increase in carbon dioxide emissions, it is basically directly corresponded with increased energy use by the expanding economy and the populations. We have basically, I will tell you one thing, there are some sort of mixed trends as far as emissions, these carbon dioxide emissions are concerned. Sometimes we see, yes, few countries or something is done to reduce these carbon dioxide emission to the atmosphere, but at the same time some trends are also showing us that carbon dioxide in increasing the atmosphere leading to this greenhouse effect. Now, the trend of reducing these carbon dioxide emissions is we have to reduce we have to get the fossil fuel consumption to the lower levels, that we should not consume more fossil fuels. We should have some energy efficient systems. We should try to conserve as much energy as possible. And we should do some carbon capturing. There is sequestration techniques, there is carbon capture techniques. By way of doing all these activities, we can basically change the trend of this greenhouse effect. Now, coming to this methane, it is emitted by the natural process sources such as wetlands. There are some human activities, leakage from natural gas systems, and raising more and more livestock will also increase the concentration of methane into atmosphere. Now, wetlands, they are the largest sources which emit carbon, this methane, simple formula CH4, from bacteria that decompose organic material in the absence of oxygen. The smaller sources, it includes oceans, sediments, volcanoes, and wildfires. Exclusively, when I talk of this human-induced methane production into the atmosphere, this is agriculture, this is industry, this is the waste from homes, our business premises. These are responsible for the production of this methane into the atmosphere. Now coming to this nitrous oxide, is it is naturally present in the atmosphere as part of the Earth's nitrogen cycle and has a variety of natural sources. However, the human activities such as agriculture, fossil fuel combustion, wastewater management, and industrial processes, they are increasing the amount of this nitrous oxide into the atmosphere. We have some natural sources. The natural sources include mainly from bacteria which breaks down nitrogen in soils and the oceans, and human induced, again I will tell you, agriculture. This, when we nitrous oxide, the emissions of nitrous oxide into the atmosphere is when we add more nitrogen to the soil through the use of synthetic fertilizers. And this nitrous oxide is also emitted during the breakdown of nitrogen in livestock manure and urine, which contribute to, there are estimates that it contributes to 6% of the this nitrous oxide emissions. And transportation, this nitrous oxide is emitted when transportation fuels are, they are burned. And industry, they also basically generate this nitrous oxide as a byproduct during the production of nitric acid, when which is used to make synthetic commercial fertilizers. Okay, and in the production of adipic acid, which is used to make fibers like nylon and other synthetic products. As far as the removal of this nitrous oxide from the atmosphere is concerned, nitrous oxide is removed from the atmosphere and when it is absorbed by the certain types of bacteria or destroyed by ultraviolet radiations or chemical reactions. Then we have these other gases as well. These we basically largely contribute to the greenhouse effect. We have some fluorinated gases. These fluorinated gases, they are emitted through a variety of industrial processes such as aluminium and semiconductor manufacturing in these industries. And they basically, these these fluorinated gases have very high global warming potential related to other greenhouse gases. These fluorinated gases are they are well mixed in the atmosphere, spreading around the world after they are emitted. Now, these fluorinated gases are removed from the atmosphere only when they are destroyed by sunlight in the far upper atmosphere. Now, in general, I can see that these fluorinated gases are the most potent and longest lasting type of these greenhouse gases emitted by the human activities. Now, as far as the categories of these fluorinated gases are concerned, we are having three main categories. That is hydrofluorocarbons. They are in short form they called HFCs. Another is perfluorocarbons, and the third one is sulfur hexafluoride. These are all fluorinated basically gases. They are also contributing to this global the phenomenon of this global this greenhouse effect basically. Now, as far as the hydrofluorocarbons are concerned, they are used as refrigerants, they are used in aerosol propellants, they are used in solvents and fire retardants. These chemicals were developed as a replacement for the chlorofluorocarbons and hydrochlorofluorocarbons because they do not deplete the stratospheric ozone layer. Okay, now this is unfortunate part. These hydrofluorocarbons they are potent greenhouse gases with long atmospheric lifetimes and high these global warming potentials, and they are released into the atmosphere through leaks, servicing and disposal of equipment in which they are used. Now another phenomenon of this greenhouse effect is the black carbon, which is not mentioned here. Black carbon, let me write so that you could remember black carbon. Now, as far as this black carbon is concerned, it's a solid particle and we call it as an aerosol. It's a solid particle, we also call it aerosol. Though it is not a gas. It is not a gas and it contributes to the warming of the atmosphere. It is an aerosol, it is not a gas. We can say this is commonly known as soot, SOT, a small particle of aerosol particles. It is in the form of a particulate air pollutant. We generally consider it, we refer to it. How it is basically is generated. It is generated when there is incomplete combustion. If combustion is not completed, then these soot particles are released. It consists of pure carbon in several linked forms. Sources is biomass. When we burn biomass, some of the biomass does not get burned properly, and this production of this soot or black carbon is there. Cooking with solid fuels, when we cook something with solid fuels, there is formation of this black carbon, which is contributing to the phenomenon of this greenhouse effect. And when there is a diesel exhaust, you might have seen the diesel vehicles and this black carbon, it is also coming out of when this diesel is burnt. Now another source of greenhouse gases I would like to give you, that is, it is a new phenomena. We call it a brown carbon, black carbon, and now this is the brown carbon. Brown carbon, is found everywhere, and it is unidentified component of organic aerosol, which has recently come into the forefront of the atmospheric research. This brown carbon, this light absorbing organic matter, this is other than soot basically, in atmospheric aerosols of various origins, say soil humics, humic-like substances, terry materials from combustion, bioaerosols, etc. Now, scientists are looking at, they are saying that the possible sources of this brown carbon basically is when we burn biomass, possibly domestic wood burning is shown to be a major source of this brown carbon. Smoke from agricultural fires is considered as an additional source of this brown carbon. And this brown carbon is referred to as the greenhouse gas. And black carbon, for that matter, for particles resulting from impure combustion such as soot and dust. These two are, now you might not have heard about this brown carbon and black carbon. These are the new variants, I could say, which ultimately contributes to the greenhouse effect. Now somebody just told me what are these global warming potential, because I have written here global warming potential. Basically, global warming potential describes the impact of each gas on global warming. So you can see here carbon dioxide, methane, nitrous oxide. These are basically the gas, different gas types of the gases, and we will look through this global warming potential. It describes the impact of these gases. Now, you know the two most important characteristics of greenhouse gases in terms of climate impact are how well the gas absorbs the energy, as we have been seeing, and we have also seen in the previous slide that how much it is preventing a gas, it is preventing this light from immediately, or heat we can say, immediately escape to the space, and how long the gas stays in the atmosphere. Okay, this is basically global warming potential. It is, when we talk of this global warming potential for a particular type of gas, it is a measure of the total energy that a gas absorbs over a particular period of time. Okay, usually we took it 100 years compared to the carbon dioxide. Gases with higher this global warming potential absorb more energy. Uh, per, it absorbs more energy than gases with a lower this global warming potential, and thus contribute more to warming of the earth or global warming. Now, as far as the carbon dioxide is concerned, it has a global warming potential of 1 and serves as a baseline for other global warming potential values. The larger the global warming potential, the more warming the gas causes. Okay. For example, methane's 100-year global warming potential is 21, as I have mentioned it here, which means that the methane will cause 21 times as much warming as an equivalent mass of carbon dioxide over a period of 100 years. Similarly, this other gases I have mentioned over here, methane, for example, has a global warming potential more than 20 times, higher than carbon dioxide for a period of 100-year scale. Methane emitted today lasts for only 12 years in the atmosphere on average. However, on a pound to pound basis, I mean to say, methane absorbs more energy than carbon dioxide, making it global warming potential higher. Nitrous oxide, for that matter, nitrous oxide, I have mentioned here, nitrous oxide, it has a global warming potential of 310 times that of carbon dioxide for a period of 100-year scale. It remains in the atmosphere. When we talk of this nitrous oxide emitted today, remains in the atmosphere for an average of 120 years. Okay, similarly, chlorofluorocarbons, hydrofluorocarbons, hydrochlorofluorocarbons, perchloroforms, sulfur hexafluoride are called high global warming potential gases because for a given amount of mass, they trap substantially more heat than the carbon dioxide. Now, I will quickly tell you when this greenhouse effect it is there. Now we know the rise in sea level basically, changes in rainfall pattern, increased livelihood of extreme events such as heat wave, flooding, hurricanes, etc., melting of the ice caps, melting of glaciers, vanishing of animal populations due to habitat loss, spread of diseases, bleaching of coral reefs, loss of plankton. These are all basically effects of these greenhouse effect which we have been studying today. Okay, thank you very much. I conclude this greenhouse effect topic. Thank you very much.